All right, welcome back, everyone. Today we're going to talk about the ratio test, but before we get that, let's take a look at these opener questions. So 3 parts here. For each series, write it using summation notation. Determine if the series converges, and if it converges, determine to what value. So we're actually going to start on part B here with this opener, because part B here gives us a good little reminder of an important type of series. So we start off with a sub 1 as our first element, then a sub 1 times r, a sub 1 times r squared, a sub 1 times r cubed, etc., etc. And we can see here that there's a clear pattern, right? From the first term to the next term, all we do is multiply by r. To the next term after that, we have another r. To the next term after that, r again. Right? And so we can see here, right, that this is going to be a geometric series, which is very good for us. So first, let's review the notation for this in summation form. So I have my sigma here, right? We're going to start off at n is equal to 0, going up till infinity. And we start off with whatever a sub 1 is times r to the nth power. So there's our series in summation or sigma notation. Now, does this converge? Well, we have a formula. What is this formula for the sum of an infinite geometric series? It is a sub 1 over 1 minus r, right? But the question now is, does this converge, right? And we should hopefully remember that this will only converge, right, if r is between -1 and +1. So this is only going to converge if the absolute value of r is less than 1, or writing this out not as writing it out as a compound inequality, -1 is less than r is less than +1. Okay, so geometric series are great, right? We have this formula, right? We know the rules for this formula. Geometric series is exactly what we want. So let's go back up now and take a look at part A. So A starts us off with 2, right? Then a 1, a 1/2, a 1/4, a 1/8, right? And we have a clear pattern here, right? We are multiplying by a half to get the next term every single time. Okay, so let's write this in summation notation, right? Again, starting at 0, going up till infinity. A sub 1 is 2. R is 1/2, right? And then this is to the nth power. Okay. And so now let's go ahead and use our formula, right? So this is going to be 2 over 1 minus a half. Okay. And so what is this going to be? 2 divided by a half. 2 divided by a half means 2 times the reciprocal, which is a 2. And so we get 4 as our final answer. Okay, so this one definitely converges as well. Okay, right, because my r value is between -1 and +1. Okay, good. Let's take a look at part C. This is where things get interesting. Okay, so we start off with 1, then a half, then a sixth, 24th, 1 over 120, 1 over 720. I'm hoping these denominators look familiar. Okay, there is a pattern here. But first, let's think of it like a geometric series, right? So 1 to a half, well, that means I'm multiplying by a half. But a half to a sixth is a third of a half. And then a 24th is 1/4 of a sixth. Okay, and so the big idea with this one, right, is that this one is definitely not geometric. Okay, and so when it's not geometric, right, figuring out if it's supposed to converge or not, right, makes it a little bit tricky. Okay, and that's what the ratio test is going to help us out with today. But first, let's write this in sigma notation. Okay, so this is n equal to 0 up till infinity. And hopefully you can see the pattern here, right? This is just 1 over n factorial, right? 2 is 2 factorial, 6 is 3 factorial, 24 is 4 factorial, etc. Okay. Okay, So again, this is not a geometric series, right? Different r's every time, so this is no good. So does something like this converge? Okay, so let's introduce our new best friend, the ratio test. Okay, so the ratio test starts off with let some infinite series, right, n equals 0 up to infinity, be a series such that, and really what we're going to do is two things, okay? We're going to do a limit, and we're going to then determine something about the sequence based on, or the series based on the limit. So we're going to take the limit as n approaches infinity of a sub n plus 1. So this is basically saying, right, if you divide the next term in the series from the previous term, a sub n. We're going to take a look at the absolute value of that, right? We're going to take the limit of it as n goes to infinity, and we're going to call that limit L, capital L, okay? And now we have some patterns, all right? If L is less than 1, that tells us that this series is going to converge, okay? If L is greater than 1, right, then the series is going to diverge. And if L is equal to 1, well, then this is inconclusive, right? And we have to use some other means to try to figure this out, okay? So this is our ratio test, all right? So let's go ahead and take a look at this in action by looking at part C, okay? So let's apply the ratio test here. I have my work kind of hidden away, right? We'll take a look at this. Okay. So ratio test, we're looking to find this limit as n goes to infinity. We're going to call that L. So what are we taking the limit of? It has to be the absolute value of the next term in the sequence, right? So a sub n plus 1 just means take your general form and replace the n with an n plus 1. So this is going to be 1 over quantity n plus 1 factorial in my numerator, divided by the denominator is just a sub n. So this can just be your general term in your sigma notation. So this is 1 over n factorial. Oops, I'm sorry, I wrote that wrong. It is n factorial in the denominator, okay? And so something like this looks very odd, okay? So how are we going to take the limit of this? You're going to do this on a lot of these questions. Honestly, the best thing to do is to just get rid of the division and think of it as multiplying by the reciprocal so we can start canceling some things out, okay? So let's rewrite this as limit as n approaches infinity of the absolute value of 1 over n plus 1 factorial times, and now 1 over n factorial's reciprocal is n factorial over 1. And now the good news is, well, what is n plus 1 factorial? N plus 1 factorial is n plus 1 times every integer less than it down to 1, which would just be n factorial as well. And so the good news is these n factorials cancel, right? And so we are left with the limit as n approaches infinity of 1 over n plus 1. And that's all in the absolute value, of course. Okay, so what's going to happen here, right? As my denominator, right, approaches, or the n in the denominator goes to infinity, denominator is going to keep on getting bigger and bigger and bigger, right? And so that means this limit is 0. Okay, so 0 is the value for this capital L, right? That's what this limit is, right? That's the L. Okay, and so we can follow the guidelines here. If L is less than 1, that tells us that our series is going to converge. Now, what it converges to is a completely different question, okay? So you'll notice most of the time when you get asked what does something converge to, right, you're going to notice a lot of geometric series in those sorts of questions. So we're not really going to worry about that right now. We're just going to focus on does it converge or not, okay? So again, this limit, right, n keeps getting bigger. This is going to get bigger. 1 divided by that, limit is 0, right, less than 1. So that series converges. That's our ratio test. Okay. All right. So we'll take a look at some examples coming up.